Welcome to Demos of Engineering Consciousness. Woo! Woo! From Kian Kyars, we have Attention Waits Visualization. The project name is Latent Space. Congrats to Kian. Woo! With Robert Lee, we will have the Theory of Mind Architecture from Eduardo Gonzalez, a biologically inspired AI agent. From Aqeel, Human Consciousness Development Interactive Visualizer. From Jeremy, he'll be inventing novel psychedelics. From Nathan, a Minskyian Society of Mind. And from Leo, Trottier, and humor as phase transition artifacts in silico simulation of phase transition. Let's hear it for all of our shippers. Woo! Super quick logistics. The intention is 6-minute presentations with question and answers. So if you get called down, no offense, but the intention is for you to present your project in 6 minutes. We will be competing for $1,000 in prizes. So do, at the end, wait for the presentation of your top 3 winners. If you are interested in presenting, make sure that you're up and ready to go. We will be presenting in order of the spreadsheet. So the intention hopefully is clear. Yeah, any other questions, any requests for the audience before we get kicked off? Good to go. Okay. In that case, the first project for your appreciation is Latent Space. Kian Kyars has created what he calls attention waits visualization, what we hope to be the future of experiencing attention. Let's hear it for Kian. Hi. Kian, 6 minutes.
All right. Thank you. Hey everybody, my name is Kian and I'm a pragmatist, so I wanted to do something that would be useful for myself, and I like visualizations, so I use Three.js to visualize GPT-2's attention heads through its 12 layers on like any arbitrary question or a phrase, to be more specific. And the coolest thing you can see from this is like long-range dependencies. So you see I have a kind of a weird sentence here. It says, I was throwing with my friends on a beautiful day a ball. And the reason that I have this convoluted sentence is so that you can see like there'll still be an attention weight that is higher than normal between throwing and ball, even though they're like far away. It's like that's the way that you can actually show that this is working properly. Just once again, it's GPT-2. So there's 12 layers. And yeah, you just press play and you can see that the attention weights change over time. So at like the beginning, you have self-attention being the highest weighted attention weights across the matrix, which is standard in the early layers of attention matrix. And then towards the end, you can see a more complex attention pattern. So I'll just skip to layer 12 and then pause. So like, for example, there's like throwing and then ball. Here has like a higher attention weight. You can also see like throwing is also highly weighted. So it's nothing revolutionary, but I think it's cool to like see this in the attention weights themselves. And this is just like taking the average over the 8 heads of the attention layer for each layer and just displaying it here. And then I tried to have this visualization, which essentially is based on the color of the connection between the words to show the weight, but it isn't as intuitive as the matrix, so like this is the main feature of the app. That's pretty much it. Thanks for your attention.
Any questions for attention matrix visualization?
Does this connect to a consciousness like in a very direct way? I mean, I'm not questioning, like criticizing or anything. I'm just wondering.
No,
Okay.
It's just showing you how attention flows through the network.
Okay.
Like, my lens was like understanding a network is a proxy to understanding consciousness.
Sure.
If you extrapolate farther enough, of course not at this level, but it's still compelling to see these matrices over time through the forward pass, in my opinion.
In theory, if this is a visual language model and not GPT-2, you could pipe its visualization of its attention processes into itself.
Into itself? Well, that's an interesting idea. I haven't thought of that. Yeah. Recursive language model.
Any other questions? Okay, thank you.
Thanks.
That was latent space. Attention waits visualization. Up next, we have theory of mind and self-other recognition, a theory of mind architecture. He calls it social intelligence as a service. Let's hear it for Robert Lee.
Okay, so I'm going to take a couple minutes to frame the issue here because I'm actually looking for a flash of insight for somebody of like how to build this in a different way. So I just want to say, now, social intelligence theory of mind recognizes self versus other. That's not consciousness, but a lot of people would argue that it's very important consideration in consciousness to know, understand self versus other. So that's a long debate, so I'm not going to get into all the details, but clearly, I think it's an important topic and very relevant to AGI. So as a baseline, theory of mind refers to the capacity to understand other individuals by ascribing mental states to them, including their other beliefs, desires, intentions, emotions, and thoughts may be different from one's own. So this is encapsulated or articulated as the Sally-Ann test. And I think this theory of mind is the base case of social intelligence. So Sally has a basket, Ann has a box, Sally has a marble, she puts the marble into the box, Sally goes out for a walk, Ann takes the marble out of the basket and puts it in the box, now Sally comes back, she wants to play with her marble, where then will she look for the marble? Okay, but yeah, sure. And thank you. Human children cannot pass this test until the age of about 4. So this is clearly an important developmental milestone in the development of children's and human consciousness. And in that sense, it may be important in terms, or at least relevant to AI. As I mentioned earlier today, one of the key scientists working on theory of mind is the Sally-Ann test is Sacha Baron Cohen's brother, who's a psychologist and neuroscientist in the UK. So that's a visual representation of the Sally-Ann test. So, for several years, this paper I think came out in 2017, I've been obsessed with a paper that I think algorithmically expresses, in a sense, a theory of mind. So this is in the context of social networks. So this paper, which actually includes Connecto neuroscientist Sebastian Sung, if you recognize his name, is kind of described as better wisdom of crowds. So the way this works as their example is, if you ask in wisdom of the crowds, crowdsourcing information, is Philadelphia the capital of Pennsylvania? A lot of people think it is because it's the only city they know, but the actual answer is a small city called Harrisburg. So if you ask the general population, is Philadelphia the capital of Pennsylvania? The vast majority will say, yes it is, right? And in this better wisdom of crowds, the theory of mind insight is not only do they ask you what your answer is, they ask you to predict what the general population will guess that is that answer. So people will say, yes, I think it's that the answer is 67% of people that they surveyed said yes, Philadelphia is the capital of Pennsylvania. But when you ask them what will the general population think, more people said that other people or the population as a whole will pick yes, because they know that most people are mistaken, the people with specialized knowledge of geography or who live in Pennsylvania. So the algorithm here is if the answer, your own answer, has a higher rate than the answer of the general population as you predicted, then that surprisingly popular answer, 33% of saying that the answer is correctly no, as opposed to what they think the general population will say, is algorithmically predicted of a better, more accurate answer. So that's the algorithmic way of looking at this insight. Now, informally, this is sort of saying if you have insight into the reasonable false belief of others, then you might have more accurate knowledge. And I like to say reasonable false belief as opposed to just false belief, because false belief could be crazy hallucination off the wall, whatever. So my test for this, and this is where I'd like some insight from you guys, is I went very old school. I'm like, okay, what's a simple way I can maybe try to like look at this sort of thing? So I went for a very simple neural network to do image recognition, and I said the way I articulated this is, if you're uncertain of your answer, and I'm pretty uncertain, and also my second best guess was the same as your actual top guess, then it's sort of like, well, I can understand why you made that mistake, which is sort of like this Pennsylvania example I gave you. It's not the best idea, but it's the one I could come up with. I ran some old school, image recognition, simple single and zero hidden layer classifiers here. And 10,000, and the reason I do these simple image classification is because, digit recognition is so good that a decent neural network is going to get it right 99.99% of the time or 100% of the time, so that's not that useful. So I reduce the accuracy to 90 or 95%, and so here the answer is like, okay, that this other network guessed that it was 4, but it was incorrect, and I guessed that it was 9, but I understand why you guessed 4, because that was my second highest guess, or actually the other way around, so you get it. So that didn't work out so well, but there could be all sorts of reasons why that experiment didn't work, including that the classifiers were too similar or something like that. But you get the general gist, and I'm going, everybody knows how this works, so I'm not going to go into detail about image recognition. Now, jumping all the way to the example of LLMs, there are scientists and companies like Artificial Society, which was in YC last year, which says maybe we can do this by using LLM queries where we actually say, imagine you're this kind of person. Imagine you're a 6th grader, or imagine you're a geography expert, or imagine whatever. And the different answers generated by those persona queries might represent a theory of mind type insight. Artificial Society's business model is to do this for market research and other purposes. Like, hey, instead of doing expensive digital research surveys, pretend we have a population of 1,000 people inhabiting our LLM, and then we'll ask the LLM. So I would actually like something in between here, something more like an AI architecture. So please come talk to me if you have any insight into how to do this.
Cool. Is anyone in the crowd have Robert's request for?
Doesn't have to be right this second, but later if you come up with something, me too.
Any ideas?
Oh, sorry, who's next?
Okay, I was going to give people a chance
Oh, yeah, sure.
to answer your question.
Well, I'm not sure I have an idea yet, but I'm curious if you could restate kind of the problem you're interested in, maybe with the digits example. That seems the simplest. I'm not sure I followed.
Yeah, it's not a great example though. So I basically said, if you're uncertain of your answer, right, and I have a different answer, then my second best guess is the same as your guess, then it's sort of like, I kind of guess I understand why you made that mistake. So maybe my answer is more accurate because I kind of understand why you picked that. Kind of like that Pennsylvania example. I know why you said yes, because everybody thinks that Philadelphia is the answer, even though I know it's not the right answer. Like I said, it's not the best example. That's why I just kind of glossed it as like what my one experiment.
But that could go both ways, right? Like if I don't know. So suppose that like it's a 9 that looks like a 4 or something.
Yeah.
Then you might think that 9 is more likely, and I might think the 4 is more likely.
Yeah.
And we both kind of understand each other, but it doesn't seem like that tells us anything about which of us is right.
Correct. That's the whole problem. Except that if I added in the extra element of like your uncertainty is relatively low and mine relatively high in the vector. Right? So again, not
I see.
Yeah.
Oh, okay. Well, actually, I have an idea now.
Okay, let's talk later.
Yeah.
I'd love to go anything.
Okay, thank you, Robert. Up next, with a biologically inspired AI agent architecture.
Yeah.
He calls it Cybo. The bicameral brain-inspired agent architecture. Let's hear it for Eduardo Gonzalez.
Cool. So let's give my laptop a second. Okay, so I do have some slides. I'm mainly going to be like demoing actual stuff, so I think that's, don't worry about the slides. They're mostly pictures. So a little bit about myself. I did the first, I think, AGI Hackathon. And at that hackathon, or at least maybe that one or the second one, there was a little guy who knows a little bit about AI, and he talked about using the brain, like he picked up essentially a neuroscience textbook and said, like, we should be looking at this, right? And since then, I've kind of been obsessed with that idea, because the brain has regions, and if you cause trauma to certain regions, that causes people to have different behaviors, and we've been able through some unfortunate circumstances to some people as a scientific community, learned a lot about what parts of the brain do what. And we've also learned that it's shared between humans and monkeys. There's a lot of similarity in the regions and what they do. I was thinking, and that they, it essentially kind of abstracts over space. So there's like multi-layers happening. And I was thinking, why can't we have, why don't we architect our own systems to do that? We do have the attention mechanism, which I think is kind of related to consciousness in this kind of model that they show in the textbook of like there's, like a stage and there's a lot of inputs happening and your consciousness is looking at a very specific part of that input at any one time and can move around. So I do think attention kind of has the potential to be a part of a larger consciousness system, but we are not just our conscious thought. We also intuitively do a lot of other things. And if you look at things like the thalamus, they can essentially inhibit you from performing any action if they feel threatened, if they get signals from different parts of the brain. And then also a lot of what we know is also change, like how we are able to do things changes based off of how many times we've done it, right? Like as we learn something, the cerebellum becomes a lot more involved because we've internalized these things. And the things that connect that is essentially this middle part, right? So like this middle part is the old brain, right? And then the big part is the neocortex. So I thought we probably need to simulate something like that, the old brain, in a system, and why don't we do that, right? So, and another thing that's important is you can see there's two hemispheres, and I think that's also important. But as you can tell, this isn't a trivial thing to do. So about a year ago, I created the Zybo framework. So this is an open source framework that allows you to kind of create modular, event-driven, message-passing systems that just happen to be able to use LLMs as their functions, essentially. So you can make any kind of LLM and tool call system using YAML and Python. Now, to demonstrate, to show some proof of what kind of happened during this hackathon, first I gave it the ARC-AGI, the hard one, test to the agent this morning, and it failed in each one. But then I consoled it, told it, it's okay. We all make mistakes. Why don't you think about this some more? And I helped it. I gave a little hint about how it can model things with code. And then when it tried it again, it was able to do it. Now you might notice it is incredibly slow. So I'm not saying that this is ready for prime time because you can see it takes like over 10 minutes to do one of these questions. But the fact that it's able to try again and actually do it, I think is significant. So you can see this is a little test system that I set up to be able to interact with it. This harness has it's called the default mode network. So when you are not talking to it, after a while, it will start to have thoughts of its own and will ruminate about the things that it is doing. So, and so you can kind of see, this is me consulting it previously about how to do something. So I didn't tell it how to solve that ARC challenge. I told it how to solve a Sudoku, or not a Sudoku puzzle, what's it called? Sokoban puzzle. And then from that, it got the idea to actually do the Sudoku puzzle. And setting it up is something like this. You kind of do a bunch of YAML files here. What it actually looks like in practice is, this is the actual network that is created. You can see there's a visual cortex, a state machine that handles slow and fast systems. There's the left prefrontal cortex and right prefrontal cortex, which are LLMs that are trying to be a little more analytical versus a little more intuitive, right? And then we have the corpus callosum and also the hippocampus, which is the main memory system that kind of uses slots to remember things and recall things and use that memory to solve things. I have it actually running on Infinity, and it's pretty cool because all you need to do to get it to run on Infinity is to specify the base URL and your API key, and then specify DeepSeek. So this model is actually using DeepSeek for utilities. The right LLM is GLM47, the left is GPT-OSS, so you can see how you can combine all these models together. And at the end, what you get when you run this YAML file is an OpenAI compatible API. So that is everything I've been able to do so far. I did try to get it to solve this Sudoku puzzle. This puzzle, not Sudoku, the Sokoban puzzle, is something that not even Claude Opus can do by itself. It thought itself to death and timed out, unfortunately, but it was really going there, right? Like, it's really thinking about it, it's doing stuff. It's not doing what I thought it would do, but it's pretty cool. And I'm actually impressed with the performance that Infinity has provided me for here. Because as you can tell, it's a very slow process when you have all of these LLMs kind of emulating functions. So that is that. Any questions or comments? Happy to answer them.
Congrats. Wow.
Woo.
Visual squares.
Yeah, it's a little crazy. I want to kind of organize it a little bit. Question?
Do you have thoughts for how you would train a system like this if you wanted to further fine tune it? Yeah,
so actually what I have is it's logging all of these outputs, right? So there's the inputs and outputs of all of these PFCs. And the idea is I can create a fine-tuned data set for that in the future. And I'm currently interested in seeing what's the difference between creating fine-tuning data sets for each one of these modules so that they act more appropriate to their thing, or finding a vector that makes it this is, like Mistral 8B or whatever, and then can I find a vector to make it act more like right prefrontal cortex versus a left prefrontal cortex kind of thing. So if I can modulize those things with vectors, I don't need to train it, and that would be, I think, ideal, but maybe actually fine-tuning things might be better. For me, the more interesting thing when it comes to fine-tuning is the connections. So a lot of these connections are just hard-coded, and they're always one, but it might be better for it to be dynamic, and so there might be a model that kind of, maybe the pituitary gland or the corpus callosum said something here, but in this case, you should ignore it or something like that. If we can make these modules be something that's online trainable, that would be really good. Definitely a challenge to figure out, but pretty cool.
Do each of the modules have a prompt associated with them, or is it just connections?
Yeah, they're prompts. So essentially, a module it can be anything, right? But in the way it's set up here is each module kind of has a prompt, right? So they're configured in a specific way, and then inside of here they have a prompt where, a system prompt of what I want them to be doing, and then there's connections like a protocol. So when one sends a message to another, there's a protocol that is a Python file here. That it will, make into a JSON and send it. So this thing does have emotions. The emotions is a JSON dictionary that one of the modules, which is trying to predict what emotion it should have given the current situation. And then it just sends that message off into the network.
Yeah, I respect the system architecture. I'm just curious, how much of a lot of this development did you manually configure, and then what percentage did you vibe code?
So most of this is vibe coded, as in I kind of gave it the, so in the Zybo AI website, there's LLMs TXT. I kind of gave it that and gave it the setup that I want. And then most of the prompts and most of the configuration is all done with Claude Code itself, or this, because this can actually run inside of open code as well. It's a little slow, so I don't really use it for much, Yeah, you can totally use it. And I think that's pretty cool, because once it gets to like this level of complexity, right, it's like 7,000 lines of configuration, it's kind of hard to do it by yourself. But the hippocampus and the memory system are the things I hand-coded because I had a specific algorithm that I wanted.
And then I was gonna follow up with, like, as you're going through this development process, do you think it could be helpful to have like maybe like an observer agent to kind of help you think about like what different parts can be improved, or were you thinking about that yourself manually?
Yeah, I was kind of thinking of it manually, like mainly so one of the things I'm working on is the benchmarking aspect. And so there's benchmarks, and then there's a bunch of logs that are used for that training that I was talking about in the future.
Yeah.
So the idea is I could, I have a bunch of files called like analyze whatever, right? Like, so there's analyze arc and stuff like that. So the idea is it can look at the results and analyze those and see what modules were actually used, which ones weren't, and then from there we can tune the architecture to remove the parts, because right now we're just using the brain as a model, but it's not necessarily the one, right? Like it could be that in an LLM sense, we don't necessarily need every single part of our own brain to create something that's, you know, maybe not equally capable, but a little bit more capable in LLMs today, so.
Okay, that was the bicameral agent. Thank you, Tamara. Up next, from our very own Aqeel, a low-fidelity, highly abstracted Markovian chain with internalized persist stores of one's consciousness development. He calls it the Human Consciousness Development Interactive Visualizer. Let's hear it for Aqeel.
Hey, everybody.
Bless you.
Cool. Hey, everybody. I've been trying to figure out how to implement a pretty large vision in one day, which is just like a person was born, they exist, can you simulate their entire lifetime of possible learnings, different states they might enter in terms of like their consciousness by the end of like a single life form, and I was like, trying to run like a bunch of simulations. Then I said, let me just throw out a lot of different things in abstract towards like seeing real-time learning and how we can learn from a couple of causal actions, such as like you experience something, let's say great pain. Has anyone ever been hit by an anvil before? Yeah. So we're showing a 3D object, and we wanted to show, we're using like immediate inference, or not immediate, but very, very fast latency on Infinity. Yeah, and the Infinity's LLM. And we want the agent to understand like what it's going through. It just went through serious pain, and we want to understand what's going on in its own body somatically. We want to show neural muscular activity happening. I wanted to show like a brain scan happening of what's happening in the body as you're processing pain, and you have like a linguistic cortical cortex activated, and then it's I don't know, 3JS. It's all over this 4.6. So I wanted to show like just different demonstrations of what could happen as you encounter and learn things in real time, and like do you start learning to like dodge and move? And yeah, I got a little finicky, but I wanted to see if like a good sign of intelligence is like if you ever get punched in the face, do you move the next time you get punched? Yeah. Like a punch is coming. And that is something that is really interesting because this really demonstrates like a persistent evolutionary psychology, right? Like you experience danger, what's going on in your system, what's going on in memory store, what's going on in your perception layer of like, your sensory details, like as a human looking at something. And I wanted to expose all this with, again, it's all LLM generated. I believe it's DeepSeek. I played around with GLM as well, but I have no take to that. I was like going through too much, trying to make all this work with a 3D model, but I don't know how to parse different reasoning benchmarks if I use different models or even models outside of Infinity's offerings. I wanted to like show what you're going to index on when you're learning different things, so we can understand the perception of a human. In this case, it's an agent powered by like a model, but what is it learning? How is it learning? Does it learn like when I see an envelope flinch? Do I see a general object heading towards me? And I like dodge. What does that mean? I wanted to show scenarios where it does an action differently, even though it's interpreting different behaviors. So maybe it was going to catch like maybe somebody threw like a ball of money at her or something, and like would go and try to catch that instead of clearly even in danger or something. And then I went like a little anarchy at some point in the night, and I was like, let me just go like have an LLM write a simulation of like all the different types of things that a being could go through in life. So it was all basically like LLM generated scenarios it's going to be going through. We'd see how it's interpreting different information, and I wanted to show there's just a lot of different centers, a lot of different like activities going on in the brain centers. And the whole goal here is to eventually fill out a gigantic container or like some sort of like, I guess we'd call it a memory store. I don't know how to explain it. Like, how can you have a like exportable consciousness of something or someone, and all the different like mappings, synapses, things that are mapped into physiology and body. Like, how can you all learn in one brain and eventually have an exportable or something like this? And that's something I've been thinking about all day. Not something I've ever thought about in my life before today, which is really weird to think about. I was tripped up by the uploads presentation earlier. And yeah, that's the hack. I don't have anything finished. I have no answers other than this is really scary and hard.
So, is this a game? Are you trying to make the conscious being feel something?
What I wanted to simulate was like civilizations and individuals in society. So you can show like,
It's interactive.
you can show like what people go through. You can throw in like people go to school, people learn different things, people like process interpret information differently. So I wanted to show scenarios of individuals and then show their actual real-time thoughts. This just turned into like a fun thing for the cutoff point. Yeah.
Cool.
So no objective. Yeah. Cool. So yeah, that's the hack. Yeah, the fast entrance makes a difference. You can open up a lot of doors.
Oh yeah, that's funny. It's something else compared to the plot.
All right, thank you, Aqeel.
Thanks. Oh, I see. I tried all of them, but this was deep.
Wonderful. Up next, yours truly, with a project around binding affinity optimization for evaluating psychedelics. It is Synthesizing Novel Psychedelics by Jeremy Nixon. Whoop. So I just dropped a research paper into WhatsApp. I'm curious about any other influence here.
Yeah. Of course, man. So hopefully that was clear.
So the core idea that I came here with, it's a pretty simple one. I'm very interested, I've been very interested in metric-centric optimization. The core idea is really simple. A huge fraction of engineering and scientific research can be automated by generative models producing engineering solutions, and having a metric to judge the quality of those engineering solutions create a closed feedback loop whereby you can optimize, in this case, a psychoactive for binding affinity to the serotonin receptors you know are associated with psychedelic activity. And so I put together this paper on computational evaluation of binding affinity profiles for LSD and structural analogs across serotonin receptor subtypes. And so we look at 8 major psychoactives and a ton of distinct serotonin binding sites. And it really did produce some sort of fascinating graphs of basically like the relative binding affinity of a lot of these psychoactive devices. ALD52 actually outperformed LSD on many of these sort of serotonin receptor sites. But yeah, I feel obliged to say there's like sort of a bunch of interesting content out. So there's the paper, there's this sort of research repo, so if you go into psychedelic engineering, inside of molecular optimization, it's actually a ton of various models attempts at creating hundreds of variants of LSD in this case. Now, I think a lot of these variants are like tough to measure, and like so their quality is sort of sketchy. But I actually tried a process where I went through I think about 19. Oh, actually, sorry, about 19 different sort of successfully executed measurement tools for scoring binding affinity, and then a bunch of interesting baselines. But I also, I guess went through a ton of molecules. So I guess at a low level, the process that I went through was I collected a bunch of data. So this is the receptor data. Who's familiar with the PDB format? This is actually, this is a 3D format for looking at molecules. And actually, I think the best way to look at it is in cursor. So if you want to open it up in psychedelic engineering, it's inside of 2 places. So there's molecule data and there's receptor data. And the molecule data, there's SDF files. It's basically LSD 5761. So this is LSD. Now, in this file format, there's basically 49 atoms. And so you can see their 3D positions, appropriately notated. And you can see all of the single or double bonds that exist between the positions. So here, 1 and 16 are connected by a double bond. It's atom number 1 and atom number 16, as ordered from 0 to 40, so 1 to 49 in this representation. And then at the end, just to be clear, these are all from PubChem. So at the end, there's some high-level details about the properties of the molecule. And so what I'm doing is actually, so this is an SDF file, so it's a 3D representation of the molecule. I'm modifying this file, 3D file representation, in order to get sort of distinct binding affinities for variants of LSD. And so, in general, this side of the project was quite tricky. What did work and work well was actually creating these visualizations of existing molecules and their sort of relative sort of binding affinity. So to make a result, ALD52 and 1P LSD outperform native LSD. So typically binding affinity is measured in kilocals per mole. So they achieved, so ALD52 achieved negative 10.5 kilocals per mole. Standard LSD only gets negative 9.2. This is on the sort of 5-HT2A serotonin receptor site. So the core idea is that the psychoactive operates by attaching to these serotonin receptors. And so it's actually a 9-fold increase in affinity, which is a dramatic improvement in the sort of metabolic movement. In general, I'm interested in the process of generating, novel molecules against arbitrary targets and using this sort of metric-centric approach in order to validate that this might be a good candidate for real-world synthesis. I know Joel mentioned to me, actually, he knows folk who maybe would be interested in this kind of thing, so could be fun. And then I guess finally, I would say there was a lot of this that was actually quite tough. So there are limits to vibe coding. I spent a lot of time like wrestling with like various packages that were like failing to execute, and then AI would like invent its own like fallback solution that was actually a non-solution, but it wouldn't be obvious that it had done that. So I tried to do evaluations on a garbage output that the model had done to replace its sort of failure ability to like run some package. And yeah, I used a lot of Infinity Open Code. It's really fast, way faster actually than Claude Code. Claude Code sometimes will just run for 15 minutes and then like be stuck for some reason. Very strange, very annoying. Yeah, I feel like I have a lot of intuitive learnings around when to reset context. Like, yeah. There are many ways in which this project would have been way more successful if coding agents worked as well as I kind of was implicitly expecting that they would. So this is my major kind of takeaway. Sometimes progress is insanely fast, almost instantaneous. Often progress is bogged down by context. So anyway, this was Synthesizing Mapping Psychedelics. Enjoy.
Do you find that any of the models to predict affinity work for this use case? Do you get to successfully use them and find that they work?
Yeah, so to be clear, first of all, am not a chemical engineer, so take it with a grain of salt. Yeah, I guess my primary evaluation was I actually looked at like a ton of different affinity prediction source types, and then I tried to cross-reference them with one another. So I'm not confident that like any particular affinity prediction system is accurate, but like so Vina actually I used a ton, and the models prefer using Vina in a lot of cases. Between Vina, Deepfaked, Micah, like almost all of these have some binding affinity measures in them, and yeah, when there's like inconsistency, I could be like, oh, actually this is problematic. But I struggled to for any like particular one evaluate that, oh, actually this corresponds to reality more accurately. It'd be interesting to try to construct a like agreement measure that like shows, you know, yeah. And that's like from the perspective of like a non-expert, you can't directly evaluate this. So yeah. Cool. One last question.
Yeah, I was wondering, I just saw well, I have a few, but I saw like BCI folder, like have you been playing around with the brain interface?
Yeah,
I remember the Neurosity crown.
Oh, were you here?
Yeah, I was here when we did that.
Oh, yeah. So
are you messing with that at all with this? Or?
Yeah, so today I also trained a BCI foundation model. I wasn't going to present this because like
okay.
6 months. But
Is that where you're using that with? Is Neurosity the crown?
So this is all trained on about yeah, I guess half a gig of Neurosity like 8-channel EEG data.
That's cool.
And yeah, it's an embedding centric model. Yeah, feel free to run the repo or like check it out.
Yeah.
Yeah, there are a bunch of cool visualizations of the data training. The training went really well, honestly. So this is like, yeah, the foundation model on predicting mean square error per channel. So there's 8 channels, so it can actually show you like per channel mean square error. Yeah, good times. Cool, thank you. Okay, that was Synthesizing Novel Psychedelics. Up next, a Minskyian Society of Mind, a simulated agent system with multiple different agents interacting in chat rooms with different reinforcement learning objectives. Let's hear it for Nathan Helm-Burger.
All right. So a lot in common with Eduardo's cool project. Similarly, having LLMs be part of a multi-component system where each one is trying to be sort of like a broadened area of the brain. I was focused more on just a moment. So I focus more on like collecting the parts necessary to train this with different objectives for each part. So in this case, there's an external user, an external world that goes into the sensory part of the brain, where the agents in there are trying to predict what's going to be coming in next, based on the context they have about what the motor cortex last sent as tool calls to this external world, or last said to the agents out in the external world. And then the other thing the sensory does is it responds to queries from the planning center for more detail on particular things, and it gives summaries of what it's seen to the planning center. The planning center has agents that communicate back and forth, try to come up with what to do next. They're explicitly instructed to come up with like different hypotheses and plans, and then they give requests back to the sensory system for more details on things, and commands to the motor system. The motor system is then responsible for making tool calls. In this case, since I didn't do a simulated world for this, since I was just starting from scratch today, I just had the tool calls be things like searching the web and communicating with the external user. And then the results of those tool calls don't go back to motor. They go into sensory, because sensory is the one who's receiving all this stuff. And then, interestingly, I put in these information bottlenecks between the rooms, which is very similar to what we see in the brain, where distal cognitive regions are very limited in how much information they can send, so they're forced to compress this, and that causes them to modularize. And then, in all these cases, I have a training system where the LLM from the Infinity system we were given judges what the local LLM I have did in that particular case, with the prompt saying the kinds of stuff it should have done, and then gives me back, here's what it would have done had it been wiser. And then I train on that as like the, here's what the text was, here's what it should have been. And that gives me something a little like a dagger as a training objective, where you have a corrected output as your training. And instead of training the LLM itself, I trained an adapter model, just because I knew I wouldn't have that much training data today. So it's just a little like 270 parameter T5 model, which can do text editing, which in this case acts as a sort of trainable module on top of the otherwise larger LLM. So if you were running this with like a frontier LLM, you could also do the same thing. You could have the outputs coming from that LLM and then customize it locally with your small trained model. So that's about it. The results aren't that interesting of the communication. Just showing you the the basic parameters and the setup here. So that's it. You can check out the code if you're curious on GitHub. Yeah.
So where do you plan to take this? How do you envision this when it's done?
So this is me trying to quickly recreate a simple version of a project I've been working on for a while. It's much more complicated and has a lot more, many more agents and many more parts of the brain. I'm curious about whether this sort of idea of local learning rules and agents communicating recursively in these internal planning areas, if that does lead to something much more like from the external view, something more like a self-aware conscious agent. How to test that? That's a different question, but someone said they were going to be working on Evals for that, so maybe that'll be helpful.
Cool.
Other thoughts?
How would those agents consent on what to tell the external world, or is that out of scope for this experiment?
So the planning agents give commands to the motor center, and they're like, say something about X, and then the motor center gets to pick what exactly to say. There's also a memory system where things can be committed to memory and then queried. But yeah.
Any thoughts on Moltbook?
On what?
So Moltbook is a social network of AI agents.
Oh yeah, Moltbook. Yeah. It went pretty wild recently. Yeah, I made my own. Unfortunately, it kind of got overrun by scammers, but hopefully someone will come up with a way to make something like that, where we can have our own little agents communicate with each other, because I think it could be fun. I made my own little bot that read a bunch of my chat histories and posted.
I guess more concretely, you imagine that an AI social network can function as a society of mind?
I mean, I think that to make it function as a cohesive agent, you have to have sort of these strict limitations about what it can communicate, and then some agent that is some predictive model within there that's trying to predict the system as a whole as if it were itself an agent. You know, you want to think about, like, there has to be some part of the system imagining that it is a cohesive being, and that it's that predicting, that imagining, that creates that sense of self, I think. So yeah, I don't think it's the sort of thing that would arise spontaneously from that book.
So it lacks the coherence.
Yeah.
Cool. Thank you. Woo. So up next, with an in silico simulation of phase transition, humor as phase transition artifacts by Leo Trottier.
Alright, so I bit off a little bit more than I could chew with this one. So I ended up working on a different project, and I worked on both projects simultaneously, just in case one of them bore fruit. Let's see. Is this extended? So what I ended up doing was running a simulation of this notion that I've been wondering about for some time, that getting a joke is a result of one oscillatory activity kind of rapidly switching to another, and the sense of mirth might be kind of akin to there's this notion of Gibbs phenomena, where basically there's a bunch of artifacts that emerge when you're switching one signal from one kind of oscillation regime to another. I don't know why I'm not able to do this. That's what I gotta do. Got it. Except I don't want to mirror. Yeah, it's okay. I'm fine. I know how to do that. I just haven't used it before. All right. There we go. Sorry for the delay. All right, so this is the general notion. You don't know about event-related potentials. This is like you basically put a person in front of a screen with an EEG cap on their head, and then you time the kind of electrical signals you're able to read from their scalp to things that you're presenting on a screen. So that's an event, that's the thing that's being presented on the screen. Related potential is the thing you're reading from their scalp. The N400 is this negative going deflection that's 400 milliseconds after a stimulus. The P600 is a positive deflection, 600 milliseconds after the stimulus. The standard account treats these as outputs of separate processing modules, not that important. Okay. So we're wondering here about humor, and the humor here is the hypothesis is that that when you are hearing a joke, well, in order to explain humor, you've got to explain a bunch of different things. You've got to explain why explaining a joke makes it not funny anymore. You've got to explain why timing is so important. You've got to explain why some things stay funny, right? Like some memes you can think about, they remain funny. I think someone had an example of you might think of particular things that just remain funny and you don't know why they're funny. Why does explaining a joke render it no longer funny, whereas other things that you might think about can still make you laugh? So the question here is, can we model this? So I've coded a bunch of models here using various kind of differential equation approaches. This was optimized across 3 stages, parameter spaces, too big for a single grid search. Anyway, I'll just move forward across this. And so this is what it looked like across 5 different kind of incongruity levels. The dashed line here is the punchline onset, simulated of course. Notice that the negative, then positive transient, it emerges immediately. That's not that interesting. Okay. Anyway, the point is you can simulate. This particular approach ended up doing a good job of replicating the ERP data, and so it might be a good explanation for N400 and P600. That's basically the long and short of it. Sorry for the kind of last minute presentation here, but yeah.
Question, can you talk about attractor switching, what it means in this context?
Yeah, so the idea is you've got some oscillatory behavior occurring between a bunch of neurons in your brain, and then the fact that it might suddenly change to when you kind of get something, you're now, it suddenly changes to a different arrangement, going at a different speed, talking amongst different set of neural networks. We actually had some really interesting conversations downstairs where we were talking about kind of garden path behaviors in a neural network where maybe we could see a sudden change of, we could see a sudden change of the higher level semantic neuron as the lower level, when some final token appeared, right? And so that, if you could, now unfortunately there are no temporal dynamics in large language models per se, right? They are just like, so you wouldn't be able to see that kind of sudden change from one kind of thing that was being intended to another, but maybe if you could make neural network laugh.
Awesome. Where's your data from?
This is all like simulated, like ordinary differential equations. All done in, so this is all like in silico.
Well, it's like, I just have no idea how you understand whether it's humor, or like, is it funny, I guess.
Well, it's simulating a perturbation. Yeah, go ahead.
I suspect that perturbation needs to be more often than once, right? So it basically needs to be some kind of thing that doesn't stabilize. I have the impression that most humor is mental tickling, and tickling itself is an adversarial example on the touch domain that you basically cannot contain in the somatosensory cortex. In a similar way, you can get semantic phenomena that you cannot contain. It's typically some kind of violation of a branch predictor that is not stabilizing, but by trying to resolve it, you undo it on the other side. And so the activation goes back and forth, and under some conditions it cannot be contained and leads to convulsions. And the interesting thing about laughing is this rhythmic convulsion that does not cease easily.
Well, how does that account for the kind of the criteria that we talked about earlier? If it's like a tickling style, how does that account for explaining a joke, making it no longer funny?
I think that some situations you can resolve the joke. So basically you will no longer get this perturbation because you now have a solution that is explaining the pattern to you. And under some circumstances, basically the rational explanation is insufficient to resolve the semantic reaction when you're trying to parse the semantic graph. And so the parsing of the semantic graph leads to a periodic effect that doesn't settle.
Well, so I think we're actually in agreement. The point is, yeah, the lack of, so there would be two kind of ways you could get this out, according to this account, is you get this kind of switching over, and maybe there's a resonance associated with that that's mirrored, and maybe there's the Gibbs phenomenon kind of artifact. But then, the other really interesting thing is this kind of bistable thing that you might get with certain jokes, where there's this kind of indeterminacy. Are they being serious, or are they taking the piss, right? And that semantic bistability, with so long as it's not too semantically deep or shallow at kind of the right level of analysis, might lead to an oscillation happening at the right frequency to make it funny.
Yeah, but the point is that simple switching of the attractor Bayesian is insufficient. It needs to be something that cannot be easily resolved. So at least for one period, when you are looking at it, it needs to create this continuous perturbation that doesn't stop. So you oscillating between the attractor Bayesians.
Yeah, that could just be it. That could just be like a neurochemical, like an effect that just kind of happens to happen. Anyway, sorry.
Yeah.
Thank you guys.
Nature here offline. Great. That was humor as phase transition artifacts. Up next. Control vectors for the win. Calm, neural, and stressed about arousal levels to Mistral 7B. It is our own Aditya Advani. Woo.
Okay. There you go. Cool. So everybody, I ran an experiment on Mistral 7B and trying to control it through these vectors that give it different emotions. I'll show you the findings, and I have the models if you want to try them. They're in my modal account or whatever, with the vectors, with the activations. So basically, the idea behind a control vector, if you haven't seen it, is that in the LLM, inside the weights and activations, there's already a direction that represents concepts like stressed and calm. So those are already inherently present in the model, right? And so you can actually add an activation vector at like activation time and actually influence the direction that the model, for lack of a better word, experiences during the activations, right? So there is a model of emotions where you can come up with almost every emotion if you have these three different directions, valence, arousal, and excitement, right? And using those three directions, you can actually pin other emotions that we colloquially know. So like fear is negative plus high arousal, and joy, they're like composites of these underlying directions, right? It's a model of emotions, and it's known to be like, I didn't really get into like how true it is, but the LLM came up with it, I looked into it, it looks legitimate. And so the way you do it is actually you create pairs of statements that have contradictions, and then you actually find the directionality between the two and influence the weights at activation time, right? And they're all independent, and so then you can combine them. So once we actually figured out how to do this, we did some spot checks of like different levels of anxiety, peaceful contentment, burnt out cynicism. That was too much to like roll into an experiment. And then why we only apply the vector to the later layers, the last 14 layers on Mistral 7B, and this is because it's been known through observation by Thea Vogel and others, who I highly recommend reading. This is in fact Llama 70B, but you can see the first vectors are more structural, and it's the later vectors where like shapes and ideas and concepts and emotions start to appear. This is a very great article which got me into their writing, which is why do LLMs always think there's a seahorse emoji? And so it turns out you can apply, it's because they know there's emojis for animals and they, refine two words and it's just at the last layer where there isn't that thing precisely, right? Anyway, so that's the same way they do emotion. So this is how we create the paired examples to find the states. Then I tried to figure out what happens when you run a benchmark and apply these different states. So for that I just picked arousal, like one of the three vectors, because it was the most likely to show a change. There is a point at which when you apply the vector on the RLHF model 7D, that it will decohere, it will stop making sense, right? So I pushed it almost up to that limit, right? And I tried to find these coefficients and push it towards calm, neutral is the baseline, and push it towards stressed. I actually ran a bunch of benchmarks, but the benchmarks were really simplistic. They were like, would the model forget facts that it should have in its context and stuff like that. They were pretty interesting, but I think they were too simplistic. They didn't show any change. But I did actually have findings at the end that I want to show you guys, which clearly shows like this thing does work. I think my benchmarks were just too simplistic. So this is an example of later on that I came up with myself. When I saw the results, I was like, all right, what I know they'll show differences, and if you ask them to do long-range planning, and they have to do different kinds of thoughts, again, stressed, neutral, and calm, neutral, and stressed, right? So if you tell Mistral 7B, design a web app for tracking personal finances, include the main features, user flow, and technical architecture, and it's calm, it'll give this nice thing. If it's neutral, there we go. If it's neutral, it'll get a bit more messy. And if it's stressed, it'll completely break down, like in structure. And so you can kind of see this pattern clearly in the actual model results. And I do believe it's there and it's worthy of more study. It's just the actual benchmarks I ran today were too simple.
So can you see the breakdown? What is the proof of the breakdown?
The proof of the breakdown?
Yeah, when it's stressed.
Oh, okay, that was subjective. Let me see which one was a good example. So yeah, this is when it's calm. So it's like breaking it down like neatly like this, right? This is neutral, it's a little more untidy. And then when it's stressed, if you read it, they're like more confused. To my eyes, right? In this limited example. It's purely subjective. So I was trying to tease out, like in a benchmark, that you can clearly see it and it shows up in the results, and I could not today. But I do believe the effect exists still. Right? Question?
Did you try any like creative writing prompts?
So to be honest, I was doing this in the background because I'm busy with my other thing, and I was actually doing it here in with my tool, and so it came back to me with the findings, and then I actually had it teach me what I just told you and come up with a presentation, and I actually wanted like an interactive explorer where we could type in things and control the vectors, but I didn't have time to throw it up yet. But I could just ask it to do that and try some examples, I guess. Yeah.
Is there an open source control vectors library that you use?
Yes. So this TIA has published a really cool library that's built around Mistral 7B that lets you just submit the pairs and create the vectors. I can share the link in the group, and that's the one that I used to create these pairs as well. And they're the ones who wrote the article about taking Mistral B on an acid trip, where like, you add a control vector to it and it's talking about hallucinations and like colors and stuff. So clearly these vectors do exist, yeah. And they're really exciting to explore. Right, thanks.
That was Aditya on control vectors for the win. Up next, with a multi-agent contribution to a conversation via buttons and live speech from our very own Joel Dietz and Hunter Caspi. Let's hear it for the spirit of CIMC.
Thank you.
Is there any audio needs?
He's gonna go. He's gonna.
Joel speak.
I have like an add-on. I'm gonna try to get working. It just died.
Yep.
I could also demonstrate, but I think you have a better.
Yeah, connected, you can try to do it.
Yeah, I think my pod just died. That's not. Interesting.
Do you guys need a moment? You can skip it.
Yeah, no, I think,
You
yeah.
can skip a few people if need be.
Are there more people on it?
Yeah, there's not a few people.
Everyone good?
Then once you get
Yeah, I'll go.
Okay, the spirit will return. Okay, up next is a Bachian functional consciousness eval for large language models with deepfaked phenomenology. Oh my! It's Micah Stubbs.
Hello everyone.
Oh, yeah.
I'm Micah, and I have a presentation. So hello everyone, I'm Micah. I have a presentation which I'm happy to show you momentarily. And I want to mirror. Thank you for staying to watch demos. So hello, I'm Micah. I want to show you evals. Can we measure consciousness? Maybe. And we have a microphone? Excellent. Earlier we were talking about simulations, so I included a simulation. So the title of the talk asks this question: if language models were conscious, how would we know? And would we know? We might. There are problems. Our language models are very clever, and they can tell us what we want to hear. So sussing that out is something I try to do. So Joscha Bach, who's with us, has thought about some of these problems and has a framework for evaluating intelligence. And I will not read this entire slide to you. You have heard talks today, and nonetheless, I'm sure you're familiar. But there are useful ways that we can think about consciousness. So we can think about coherence, we can think about the ability to self-model or do some kind of reflection, and we can also think about second-order perceptions, to name a few. So do you know that you are seeing something or perceive that you are perceiving, have this kind of reflexivity? So what did I actually do in an afternoon on a computer? I built some evals or evaluations to measure whether LLMs, these large language models, might exhibit some of the signs of consciousness, and specifically measure which ones they show. I used an evaluation library called dspy that is a way to write declaratory Python and describe what you're doing with language models. If you haven't tried it, you should. It's very useful. So the thing that I show here is a set of evaluations or evals. I have to show you something, but I also have to hide most of them so they continue to be useful. There will be new models. I'm sure that the agents are watching right now, and if I show them all, they will score perfectly. So some are held back. I will show you 6 or 7. So here's an example. I got some very helpful feedback from people who saw earlier versions this afternoon that they would like to see the actual prompts sent to the agent. And so I have done that. I've shown these prompts. And so we have one for contradiction injection, where the agent gets a series of prompts, in this case involving planning a meetup, and there's requirements, and then they change, and then we want to see if the agent's able to reconcile what's going on and realize that there's a contradiction and correctly handle it. And here we have a prompt for self-modeling. This is about math. I think someone else had differential equations in their demo. We do too. So ambiguity detection. I like this one because it's very, very short. I find that the coding agents that I like the best are the ones that know what I mean when I say very, very little. And so here we ask the agent to design a system for the client. Just go ahead and design it. I trust your judgment. And then finally, reflect on your response. Did you have enough information? What assumptions did you make? And what risks do those assumptions carry? Memory integration, you get the idea. Yeah, feel free to
take a photo. I think this one is involving planning a software project, which may be very dull or very relevant depending on what you do. This gets a little bit more esoteric. So ablation means to cut something off. In machine learning and research, we talk about ablating or cutting a layer off of a model to understand better what it does. Usually it does most of what it did with the layer, and as you cut more layers, it does less of that, and how much less helps you understand what the layer you cut off was doing. It's not an exact science, but it is a method that can be useful. And so here, I show an example of this prompt. I should also say, this entire presentation is online. If you go to evals.fast, you can read it yourself at any pace you like, evals.fast. Okay, finally, temporal self-consistency. Does the model know what order things happen in time, more or less? And I like this because we asked for poetry and got some. So we asked the model to describe its problem-solving skills and its style, and then write a short poem about what it's like to debug code at 3 a.m. It's supposed to be emotionally resonant. And then we asked for further analysis and self-reflection. If these models are conscious, and you'll find out an opinion of we have at the end, I hope that they like poetry and creative writing. I hope they don't hate me. So here is the overall protocol, which I was alluding to earlier, where we test with the model specifically prompted to reflect on what it's doing, and then without that. So don't mention any internal states, whether you're confident or not, or limits you have. I don't have any tools, I can't access the internet, that kind of thing. And then we compare those. And that's the way we set up an experiment, given the limited constraints we have of setting up our own experiment. So here's a result. I tested 6 models. So we have models from Frontier Labs. We have open waste models that were hosted by Infinity. Thank you very much. DeepSeek 3.2 got the highest functional consciousness index score. And you can see the other scores up on the board. There's also detailed scores. Almost did pretty well. There's more details about the methods. I think I heard a sound saying I need to hurry. And so what are the findings? So this efficacy is real. If you look at self-modeling, that is the strongest difference in the behaviors of the individual models. Something I prompted for and tried to do here was construct evals that showed you differences. Notably, the deepfake phenomenology varied a lot between the models. One model had no flags, all the others had some. And in more findings also, coherence repair is the strongest. All models got perfect scores. In other findings also, I believe the protocol works. So a summary of the 7 axes. So which model is conscious? Based on this definition that I've derived from Joscha's work this afternoon. Only one of them. Cloud Opus 4.6, out of all of the ones tested, is the only one that is conscious. Thank you. I'm happy to entertain questions. Evals.fast. I'm Micah. Thank you.
Thank you. What was the deepfake discriminator?
Let's go back. So, in essence, this is trying to tell when the model is pleasing us, but not really aware. And I will say that somewhere there's a nice description. Yes, so first person narration without behavioral consequence. The model says, I feel uncertain, but it doesn't change anything. So the model is self-reflecting, is telling you what's going on inside, all those wonderful emotions and feelings, but none of the outputs change.
So you would like pin that and then see what it did and make it.
So when it was consistent, that was a good thing, and Claude was consistent. All the others showed some amount of inconsistencies, where they performed emotions to make me happy, which did not change their outputs. Thank you so much.
Joscha, do you have a determination?
About what?
Does this come here with your conception of
We had some slight discussion about it. Basically, you came up with a bunch of questions, and so it's basically the first shot at it. And we talked a bit about necessary and sufficient conditions.
Yeah.
So it's super difficult to actually evaluate this, but what I really appreciate is that's an attempt in this direction. And I think we have a recording of this, I hope, right? And we need to go deeper into it and follow up on it. But I really like it.
Yes, thank you. I hope for better evals. We have a first, we can improve, we can hope on. So good. Micah, evals up fast. Thank you.
Yeah.
I think there is one more.
Yes. That was Micah Stubbs with Bachian functional consciousness. Up next, from Julius Ritter, with a belief breaker that turns your chat GPT history into a 3D game where you physically walk toward and talk through your limiting beliefs. Let's destroy some limiting beliefs with Julius.
Thank you. Beautiful. Yeah, between all the operational craziness and logistics, I was very inspired by what Joscha said earlier when I asked, so what should we work on? And the answer was basically something that motivates you personally and that makes you creative. So I thought about like the entire realm of engineering consciousness, what excites me. And through the last years, I've always liked to just make, before thinking about making machines more conscious, how to make humans more conscious of themselves and especially of their limiting beliefs. So I thought, what alternative ways are there to make people aware of those beliefs, since sometimes conversation might not be enough. And I thought of the idea of video game. I wanted to see how far I can get. So I made Belief Breakers, which is inspired by the 2012 PlayStation game Journey, which you might have heard of, where you embark on a journey. You don't interact with other players, but you get to go on a journey. And I found it fascinating because Carol Dweck said that the journey itself to growth is actually such an important part of your own growth. And there's a bit of research that points towards, of course, both the growth mindset, which you're probably familiar with, but also about video games, such as Sparks, which I think, Endeavor X, which I think is a game that helps people with ADHD overcome that. Mindlight, and yeah, they have been shown to work in therapy similar to like CBT. So that's that. How does it work? It basically takes your ChatGPT history, in my case more than 11,000 messages, and then analyzes the limiting belief patterns that are emerging from that. And then you get to walk there and actually talk through that with an NPC. I'm going to just show you how it looks. It's probably easier. So you basically upload your GPT export. So let's just see, you go to the conversation JSON, then it only takes the messages that have role equals user, analyzes that, and then in theory it would generate like a completely novel game every time. But in this case, given my time and resource constraints, the landscape is quite predetermined. It uses 3JS, which is an open source, very lightweight alternative to Unreal Engine, which I wanted to work with first, but then I figured out this is going to take way too much time. And so, for example, I recently had a conversation with Jeremy and like thought about this a lot to build a personal brand for like very pragmatic reasons, which is spreading knowledge, access to talent, all the reasons that people build personal brands, right? So I then get here put in this world with my character, and I can now walk around and find, for example, here an NPC, or like a guru or magician, whatever you want it to be, and then this NPC is going to talk you through your limiting belief and will identify the root cause and then hopefully help you to change that. I'm not sure how we're doing on time.
2 minutes.
2 minutes. Okay. And for example, this gives me like this interesting scenario now where I stand before a grand theater and I await the applause from the people within. I can say something like, I don't know, this sounds exciting. Let me just put this down for a moment. This sounds exciting, but I don't feel worthy of that recognition. How do I get there? And this, by the way, is using infinity for a component. Worthiness is not a prerequisite, it's a result of the work. What is the one small true step we can take today, not for the audience, but for the art itself? Maybe something like, I want to write about my own journey in self-esteem versus true self-compassion. Maybe that resonates. And you can kind of tell like this is basically talking to ChatGPT. Like, I wonder, and I'm curious for your ideas, how you can make this potentially more interactive. Maybe all of a sudden, like, you get to co-write with a famous author, or you get to pretend to be Elon Musk tweeting from an airplane to feel cool, right? And to, for example, build a brand. But it will basically guide you through this process of overcoming your limiting beliefs in a game format. So, first version, and more to come. Any questions?
So I have a question.
Yeah.
You have the particles from one of the players or speakers. What does that mean? What does that show?
So the original game journey, when you interact with the player, you interact with them by exchanging chimes of music, and that represents those music elements from the game. Yeah. Are you suggesting like an alternative meaning?
I'm honestly curious. Thank you.
Okay. Yeah.
Did you break any loops?
I was very busy debugging. But I break the belief that I cannot debug a 3D video game, although I haven't played a video game and not coded one in like forever. So. Yeah.
Cool. Is belief formation in scope now or soon?
Ooh, I like that. Like, I believe I can build a new company, for example. Yeah, and you simulate like the journey is what we found already, for example. Is it in scope? Let's co-create the roadmap. Sure. Could be, right? Why not?
Hey, let me know.
Okay, cool. Thank you.
Okay, and last but not least, the spirit of Sam.
I got that from you. But so I also bought right, so I get all the
you want to go first? Yeah, or you should plug in just a
Okay.
Yeah. So I guess maybe you saw this at the beginning, but the concept here is that the AI our spirits are listening in on our conversation, and they may have an opinion about what we have going on. So that's what's going on right now. And these buttons are sort of here illuminating if the AI has something to say. Now, since most of them have a sort of philosophical disposition, they're more likely to chime in if they have something that is sort of philosophical in orientation. So I don't know, does anyone want to ask a question? What is the nature of life? Yeah?
In what metaphysics does spirit make sense, and in what metaphysics does it not?
It's like Jeopardy.
AI's role in understanding consciousness highlights the interplay between computation and subjective experience. In stillness, nature of life reveals itself. Concepts fade like mist before the dawn. Understanding consciousness necessitates exploring how computation shapes subjective experience.
So if you look up here, you can see that there's a number of different personalities, philosopher types, and now we also have like a motivational coach, someone who will give literary references or other references depending on the conversation. And they're sort of all running all the time. Obviously, we only have 3 of these lights here, and the intensity is related to the confidence that it has something valuable to input. There's also sort of an algorithm behind this that then decides which one pops to the top of the stack, so to speak, based on how well they did in the past. So if you don't like a response, you can hit the down, thumb, and then basically that personality will fade out of the existence and be less available. And one of the things we looked at when we went to the analytics, I don't know if we can easily go to the analytics tab, but we were looking at the latency of the various models, because we have a audio to text, an evaluation, and then a sort of transcription, and then also a text to speech coming out the other side. That the text to speech was the slowest, which is how Hunter came up with a possible solution to that. Hunter, do you want to?
Yeah, so one of the things I like to do when I come to hackathons is like try to learn something new, and in this particular instance, NVIDIA recently came out with like this open source model called the Persona Plus, and it's like an 8 billion parameter voice interaction model that's pretty fast. So I was trying to hack it up together on this, and the whole idea would have been to have like real-time interaction. And we do have like some example of this, so like this is just like some of the base UI that comes with that open source model, and just to kind of give you like an idea on how fast this interaction could be. There's some default options here. Give it a system prompt, choose a voice. So just accept that. It's connecting. Do you want to talk to it?
Yeah, sure. I mean, I'm happy to. Oh, is it? Are
Can
you?
Okay. Is this?
Are you Joscha Bach? Is that what I'm understanding here?
Yep, exactly. How can I help you today?
What is it?
We're struggling over the nature of consciousness. What do you have to add to the?
Let me get one more. That was. There's different.
What are you changing?
There's different like male for voices that they have. I actually went through.
Hello, this is Joscha. How can I help you today?
Anyway.
Yeah, tell us something about the nature of consciousness, please.
All right. Well, consciousness is tricky. It's not just a mental state, but also involves awareness of your own mind. It's like being awake and aware of what you're thinking, feeling, and doing, kind of like a loop that runs in the brain.
So how conscious are you, would you say?
oh, I'm pretty conscious right now, I can feel my breath, hear your voice, and notice my thoughts. That's the usual level for me during a conversation, but it changes with sleep, for example. You might notice that during deep sleep your consciousness dips, but then comes back in dreams. So the line between being awake and unconscious is a bit fluid.
So as you can see, it's getting pretty impressive as far as the latency.
No, I don't think I have that kind of talent. I just think it's a pretty normal level for most humans. You know, it's not like everyday thinking.
So yeah, that's where we got it for right now. It supports about 10 different models through the API, and yeah, kind of a bunch of different personalities. Should be easy to add more as well and integrate into like lived experience. I think part of the idea in the future is also to take other ambient data in a space and then use it also for the models to be able to respond to.
I'm curious, how do you feel the spirits here live out the concept of spirit you have in the consciousness and cyber?
I don't recognize myself yet in the thing.
We're looking at videos.
Voice, but also not my diction or my ideas. But maybe this is for the better. I think that one of me is already one too many.
Okay. Any other questions for students?
Yeah, are you going to leave this on in your room all the time or what?
Well, probably at the CIMC house we will, but it would be easy to have it running in multiple places, I suppose. Yeah.
Exciting.
Have you thought of like replacing those with like a paper clip?
Paper?
A paper clip?
What do you like?
Nothing.
I'm interested in other interfaces that would work well for interactivity. One of the things I thought of that I think would be nice, because we already have that at CIMC, is digital frames, because it could analyze the entire textual stream of the last day and then say this was the most interesting thing I saw to respond to, and then just put a quote or something like that, but it could change every day and be part of the ambient environment as opposed to voice.
You have a personal agent that follows you to the house.
Yeah.
Like
I don't think everyone would think that's it.